So next topic is about research method. In research method, chapter 2, model of scientific inquiry. Inquiry. So scientific inquiry generally termed as a variety of techniques used by the scientists to explore the natural world and propose explanations based on the evidence they find. Or in other words, these are all diverse ways in which scientists study the natural world and propose explanation based on the evidence derived from their work. It aims to obtain knowledge in the form of testable explanations that scientists can use to predict the result of future experiments. Generally, scientists use three types of investigations to research and development explanations for events in the nature, like descriptive investigation, comparative investigation, and experimental investigation. So other definitions of scientific inquiry is to find and to characterize the patterns as results from the explorations. Scientific inquiry is founded on experiment and observations as opposed to purely rational or isolated logical thoughts, or it can enrich our understanding of science. Why we need scientific inquiry? Because it makes you more knowledgeable about something. You will be able to explain about something more thoroughly. It will make you a more literate and cultured person. It will provide you more ideas. There are 5 features of scientific inquiry. The learners engage in scientifically oriented questions. Learners give priority to evidence in response to questions. Learners formulate explanations from evidence. Learners connect explanations to scientific knowledge. And learners communicates and justifies explanations. There are some certain characteristics of scientific inquiry. They are: scientific inquiry is made based on facts. It based on objective consideration. It based on analytical skills. It is quantitative in nature. Deductive logic, that is hypothesis, and inductive logic like generalization. So deductive logic means from a general predictions or general explanation, they are coming to a conclusion. Inductive logic means from a conclusion or from a single point, they are going to make multiple points or multiple ideas. So there are some steps in scientific inquiry: ask questions, hypothesis and predicts, test the hypothesis, analyze the result, draw the conclusion, communicate the result, carry out further inquiry. So like making observations, posing or posting questions, finding out what is already known, planning investigations, review your past knowledge in light of experimental evidence, using different tools, different data gathering tools or analysis tools for gather, analyze and interpret the data, propose the explanations and communicate the final result. See, observations is more important because in certain kinds of experimentation or certain kinds of requirement gathering or information gathering, we may not get the proper information. So during observation, it is easy for us to observe the activity, and according to that, we can come to a conclusion or we can gather the information. So this is the block diagram of general model of scientific inquiry, starting from state the general problem, conduct literature review, state specific problem, design the methodology, gather the data, analyze the data, report the results, and refine the hypothesis. So once again, general model of scientific inquiry: state the general problem, conduct literature research or a review, state specific problem, define the methodology, gather the data, analyze the data, report the results, and refine hypothesis. So one more model, that is like problem statement, organize the critical thinking framework, organize premises, hypothesis formulation, testing the hypothesis, and from them draw the conclusion. So here the general model is explained one by one. What is by state a general problem? That means statement that is stated in general general in nature. Example, will the universe expand forever? That means it will be like a common problem, or it will be like a common question. So these common questions we are having, and from that we are making comparative studies. The second step, that is conduct the literature review. So what you want to do is that whatever the available literature which is available, what are the available literature on internet, on books, on journal articles, etc. You need to collect, you need to state the problems, and what you want to do, you want to collect, underline all the theories, techniques, methods, findings, and etc. And what others, or what other researchers, or what other scientists have found. Then you need to critically analyze. You need to analyze, or you need to go through thoroughly their weaknesses, their strengths, their similarities, their dissimilarities among those theories, techniques you found in the literature review. And then what you want to do, you need to summarize those literature, and whatever you had taken from, for example, you are taken from an author, you are taken from a researcher, that should be cited, and the same will be included in the reference section or in the bibliological section. Then specific problem, that indicates a statement of general problem, whatever the general problem, common problem which you are having, that common problem you are deriving it into some specific problem. For example, like what are the factors that cause the universe expanded? So in the first category, it indicates that universal expansion, which is common in nature. So here they are mentioning about factors. So they are pointing in certain points or certain steps. Then comes design the methodology. So you need to list all the steps to be taken in order to answer those stated problems in the previous step, and establish the setting of experiment. Provide all necessary means, all tools, all instruments, etc. Then define the objects and variables. Finally, gather the data. So how you are going to gather? You are going to gather the data in the form of documents, and that documents you will convert it into tables or graphics or etc. Then analyze the data, interpret the organized and processed data, then finally report the results. So here, what are the steps we are going to do is that state the general problem, conduct the literature search, state specific problem, define the methodology, gather the data, analyze the data, and report the results. So this is a simple form of scientific inquiry. Make a natural phenomenon, make a question, derive a question, provide hypothesis. So hypothesis, so we can tell that it's an explanation, or it proposes a tentative explanation or prediction. This hypothesis may be proven true or false by testing and experimentation. And on the other hand, a theory is a substantiated explanation for that occurrence. Then comes experimental plan in order to test the hypothesis, then predicted result of the experiment, and then experiment, and finally comparison of this predicted and actual results, making conclusion. What is the conclusion? Either the hypothesis is correct or hypothesis is incorrect. So this is the simplest form of scientific inquiry. And in addition to that, we have the model development. Same thing, but instead of that, instead of hypothesis, we are making the model. So a natural phenomenon, a question, a working model, whether the model is correct or not. If it is not, propose another model. So experimental plan to test the working model, experiment, comparison of the result with the model predictions, and during that, if the model is acceptable, accept it. Otherwise, we need it requires revisions. So the key components of scientific inquiries are scientific experiments, model, as well as natural phenomenon. The basic skills needed for scientific inquiry, like observing, classifying, sequencing, communicating, measuring, predicting, hypothesizing, inferring, defining, controlling, and manipulating variables in experimentation, designing, constructing, and interpreting models, interpreting, analyzing, and evaluating the given data. The different uses of scientific inquiry: make connections with the world situation. So that means you are going to be a knowledgeable person. So from one point or one questions, for example, one problem, for example, you are going to gather multiple data to find solutions for it. Automatically you will be knowledgeable, or you will be an expert in that particular domain. To encourage more active problem solving approach to learning and thinking, to apply the mathematical skills, review what is already known in light of experimental evidence, propose the answers, explanations and procedures or predictions, use tools to gather, analyze and interpret the data. So problem identification. So you need to, whatever the problem that you are going to find, that problem should have some value, or it should have some weightage. Sometimes the problem which you are making may not have a, or may not be researchable. Why? Because that should not have any impact on the scientific field. So determine a well-defined general problem, exercise your thoughts to express the problems, write them as quickly as possible, be ready that some of your general problems are not reachable, conduct literature review. So that means whatever the problem that you are finding, you should know that whether the problem that you identified is researchable, identified is valuable, identified problem will have an impact on the scientific field, etc. And once if you identified, yes, it is researchable, then you can do either literature review, or you can consult with the experts or subject matter experts, SMEs. So if there is no problem, automatically there will not be any research. Surely everybody will agree on it. No research, sorry, no problem, that means no research. So the formulation of the problem, identification of the research problem, identification of the scope of the research. That is important, scope of the research. Identifying the research questions and identifying the research objectives, automatically it will take you to the statistical hypothesis and hypothetical statements. So there are two types of hypothesis. One is hypothetical statement, which does not use statistical analysis or statistical measures, whereas that of the statistical hypothesis uses statistical analysis. Define or determine the research objectives. Make sure it is compulsory, or it is indeed, it is necessary to know that you should have a strong reason that why such a research is worth doing. Study the impact of the research, study the impact of the research problem, and study the usage, etc. And then finally, research objective should reflect the solution of the problem. If you cannot state the problem, you cannot state the objective. Build your reason based on the fact, like previous studies, existing problems, comparative studies, etc. So this is all about scientific inquiry. As a conclusion, we can tell that scientific inquiry refers to the diverse ways, refers to the different ways in which scientists uses the natural world to propose explanation based on evidence derived from their work, and it aims to obtain knowledge in the form of testable explanations that scientists can use to predict the result of future experiments. That's all this chapter. Hope you understood the concept. If you're having any queries, please write to me to the email ID provided on the first chapter. Thank you for your patience.